This is the video presentation for the project eSpeech Therapist. Over 5% of the world's population suffers from disabling hearing loss. This number is expected to double up by the year 2050. Due to lack of speech therapists and low cost accessible equipment, it becomes necessary to develop an inexpensive system to help hearing impaired children to learn how to speak without depending on a speech therapist entirely. So, with this project, our aim is to build a tool to teach partially deaf and hearing hard people to pronounce vowels contextually, to introduce a method that does not purely rely on speech therapists, to use interactive features such as children friendly computer graphics, videos, speech processing, and image processing to make the system efficient, to design a real time system that educates the user about the place of articulation of the vowel sound, and lastly, to develop a software that can be used remotely. So the resource requirements for this project are PRAT, the software for signal analysis and format extraction, Python speech processing libraries, Python image processing libraries, Windows or Ubuntu, web browsers, internet connection, Inkscape for graphic design, and lastly, Synfig for animations.
Thank you, Nandini. So coming to the web app part, so the front end of the web app is written on JavaScript, whereas the back end is written on Socket IO. The reason why we use Socket IO is because we are generating images from the website to the server via WebSockets. Socket IO is extremely easy to use and has a good documentation online, but we have faced lag issues with that, which we will be covering later. So this is the interface design. So for now, we have only worked on the vowel E. This is the area where input sound is taken and formants are extracted. So for the particular vowel E, we have a set of range which will indicate if the vowel generated by sound is correct or not. Here we have the animation for the letter E. This is the front lip movement. This is the side lip movement. And this essentially shows the lip as well as the tongue movement, which the child can refer to. For the format extraction part, we have used LPC. For face detection through video, we have used HAR Cascade. For the lip detection part, we have used DLib library for facial landmarks. And finally, for the detection of E through lips, we have used Linnet architecture to train our model. As you can see, the waves are a lot of waves are generating here, which is essentially because of the noise in the background. I will show you the demonstration now. So to enable the video, I have to press this button here. E. So as I said earlier, because we are using Socket IO, there is a certain lag when it comes to the server FPS and the website FPS. So this is one of the limitations that we have experienced while using Socket IO. As you can see, there is a lag, but it is detecting E. I can run the same file on Jupyter Notebook to show you the accurate results for it. E, e. This is um, the design of our web app along with format extraction, lib boundary detection, as well as detection of E. Over to Nidhi.
In conclusion, we have implemented a system that performs form and frequency extraction as well as lip detection for the vowel E, and we have integrated that with our web app. We have, in addition to this, visited multiple clinics to doctors who have understood speech disabilities and explained them to us and also told us how they perform speech therapy. This also helped us locate a gap in the market since there are already apps out there such as Jello and Avaz that work well with speech therapists, but our app actually provides an independent system for the user to practice between speech therapy sessions. Our system, of course, does have a few limitations as of now, and one of them is that the shape of each person's mouth to produce the same sound, which is E over here, can differ. There is also a lag, as Dania mentioned, in the video output. The future scope of our project is immense. It can in fact be expanded even in the hardware form by including something called palatography, where we use sensors to monitor tongue and jaw movements of the user. Image and speech processing can also be done for vowels and include labiodental consonants such as f, v, and p, which show lip movements as well as the teeth movement. Further, we can also detect the relative frequency range of a user's voice, and the formant frequencies can be adjusted to that person's range for more accurate results. Thank you.